Today's video, I will be doing the experiment 5 entitled Half-Wave Rectifier Circuit with RC Load. The objectives of this experiment is to simulate the half-wave rectifier with RC load using PSpice software. To utilize the software to observe the behavior of half-wave rectifier with RC load and to determine the various quantities using PSpice software. And we have to create this circuit in the PSpice and follow the procedure to set the resistor value of 2 ohm and the capacitor value of 100 microfarad with a run to time of 16.67 ms and the maximum time step of 10 qs. In order to complete this table, we have to simulate the given circuit above in the PSpice. We have to create a new project, name it experiment 5, click OK, and then create a blank project. To get the angle theta, we just have to add the voltage probe here in the resistor and in the source, and then click run. This is the waveform. To get the angle theta, we have to change the axis settings, axis variable, and the trace expression into time times 60 times 360. And then the angle theta value is 90.236 degree. To get the to get the maximum output voltage, we have to remove this voltage probe here in the source and then click run. So the maximum output voltage is 310.127 volts and the minimum output voltage is 167.573 volts. To get the change in the output voltage, we have again to add the voltage probe in the source and then click send. and then the change in output voltage is 142.554 volts. We also have to get the peak of the diode current, which is the ID1, and then cursor peak to get the value of 11.767 ampere, and then the peak of the capacitor current, (1.5321 ampere). For the second part of this experiment, or in the table 2, we have to get the average value of the diode, which is the ID1, which measures 2.1239 amperes. And then we have to trace the RMS value of the capacitor, which measures 4.2536 amperes. We also have to get the average value of the resistor, average power value of the resistor. Which gives 269.462 watts. We also have to get the average power of the voltage source, which measures negative 357.615 watts. And lastly, we have to trace the average power of the diode, which is the WD1, to get the value of 3.9198 watt. For the conclusion of this experiment, since the ripple or difference in output voltage is so high, the capacitor is ineffective as a filter. In certain applications, producing an output that is similar to the DC is preferable. This requires a broad time constant RC in comparison to the length of the input voltage, resulting in minimal output voltage decay. The output voltage of an efficient filter capacitor is exactly the same as the input peak voltage.